All right, we can go ahead and get started. Thank you, everyone, for joining us, whether it's the afternoon or the morning where you are at. But we are very excited for the second webinar in our series the FSSA and FPA Australia are doing this year. So I would like to welcome our three presenters for this meeting, Joe McIlvaney, Justin Morris, and Carlo Trivia. And I will hand it off to Joe to start us with the presentation.
Good morning, good afternoon, everybody. You should be able to see my screen right now, hopefully. Is that a good, fair statement, Becca? Yep, okay, perfect. So we decided to do a little talk on AFFF replacements and kind of see where we're at and what we're doing and compare how each group is doing it. Of course, we always have the disclaimers. So here's a couple of disclaimers. Here's the disclaimers for our discussions on some NFPA and ICC committees. One of the first things I want to do is refer everybody back to the FSSA homepage. We have two resource centers, documents or information. One is on AFFF and one on PFAS. I won't go over these in great details, but they're there for people to review and see, and we are trying to always update them as possible. But as you know, time and energy is always a challenge. I'm going to talk about four major things, I guess, really with HFF. Is the scale of the problem, what the landscape of the legislation and laws are being, some disposal methods, and a couple of case studies, and talk about some things I see out in the field and get people thinking about things. So the scale of the problem, here in the United States, we have over 1,000 plus places where we think we have PFAS or more. The cleanup cost is $1 billion plus right now. Nobody really knows how much AFFF is still laying around. If you talk to your local fire department or your petrochemical facility or aircraft hangar, how much is it still sitting there that potentially can still leak? There's over 1,000 lawsuits. Just today, I saw Australia is suing 3M. That made the news today. So if you didn't see that one, but that's 1,000 this year in the United States. Settlement reached today is a couple $2 billion already, and contamination sites nationwide is a big question. I don't think anybody really knows where they are. I found a map that I'll show here in a minute that kind of talks about that a little bit, but I don't think it's completely accurate. And this is a map that I found on the internet on dated March 5th of 2026. And it talks about all these sites that are potentially have PFAS in the drinking water or so forth. And what's interesting to see, it's near all your major cities here in the United States. I guess in Wyoming, Montana, Iowa, North Dakota, South Dakota, you may be okay because it's less populated, more with elk and deer and stuff like that than people. But those are the sites. On the federal and state regulations, here is the federal landscape, what's some of the big items that's been happening. As those who know our state, the way the EPA is going right now, they can't make up their mind. I'm going to be honest with you, which way they're going to go with PFAS and what's the level. The last numbers we heard was 4 parts per trillion. 4 parts per trillion is pretty hard to detect, right? But that's the number now that they want to have in our drinking water. Will it go into effect is the question, I guess. They have some guidelines for disposal, but it's not official. And Department of Defense is trying to get it phased out by 2026, but they probably won't meet that deadline either. But on the state level, we are seeing great activity. Every state is regulating PFAS in many different fashions, from AFFF to PPE to cosmetics to food containers and everything else. The biggest one that just came out this year is probably New Mexico. They have now really caused PFAS and AFFF hazardous waste. And I think that's where it's probably going to end up going, that direction. And for us in the States and Australia, when you say road hazardous waste, just costs more to clean up and dispose of, right? It's just more dollar signs. Um, this website here, which we'll share later on, also kind of gives you a um, most up-to-date status of all the rules and regulations dealing with PFAS in the United States, state by state. And this is always being updated, and I find it very useful. Disposal methods in the United States, we're doing the three types. Hazardous waste interstate burning, landfills. These are specialized landfills dealing with hazardous waste. Your municipal waste that you throw out in your trash can is probably not the recommended location, and deep well is not recognized yet. Some challenges and some reports I've been reading, though, is when we incinerate or burn off the hazardous waste PFAS materials, they're saying there may be some PFAS going out in the plume of the smoke. So the question is this really the best way to do it or not? And I don't think the scientists have figured that out yet, and it'll probably be another 20 more years before they figure out the best method or that causes less challenges for us. Now I'm going to talk about listings and approvals and where we are with that in the United States. The first biggest thing I think we have to remember is when we talk about listings and approval, either UL or FN, which are the two main groups that we get listing products for or approved for, the bladder tank, the proportioner, the concentration, and the discharge device will all need to be replaced most likely and must be listed together. So what I'm saying here is if you have an existing bladder tank and you wish to take out the old bladder and put a new bladder in, the odds are you're not going to have a listed product system. If you think you could use the existing sprinkler heads or discharge device, the odds are you probably won't be able to do that. They're probably not listed for the new foams, concentrates, because these concentrates are so new. The manufacturers have not gone out and tested all the old discharge devices. So at a bare minimum, you should be replacing the whole bladder tank, the proportioner, the concentrate, and the discharge devices. And we'll talk about the other components here in a minute, where I believe we should be going. UL has a great website where you can see all the listing information on what's available. And this is that website there. And FM also has the same thing. And this is where I go all the time, or you can talk to the manufacturer's representative, and they will gladly tell you what parts and pieces are listed together or not listed together. So when we're talking about the foam and the new foams and what we're going to use, some of the things we got to think about with this discharge device is the K factor, what fuels the foam has been tested to, what approvals they have, the minimum application rates, the minimum inlet pressures, and the foam concentrate type. I will tell you we found multiple cases of existing systems that we questioned how they were designed back then using the old codes and standards. We are also finding great challenge with fuels. The manufacturers have done a wonderful job getting listing, but they haven't listed to all the products we're testing and protecting. And so on a regular weekly basis, I'm sending safety data sheets to the manufacturers saying, I'm trying to protect this facility with these fuels. What design concentration should I be using to protect the hazard based on your foam? Because they're not listed that way. They're not listed for the new chemicals that we're seeing. And then they end up sending us an email and saying, we need further testing and please get a sample, or please use a density of point whatever over so many square feet. So I think you all have to be very careful about that to make sure that when you're picking the discharge device, looking at the K factor, looking at the fuels that has been approved, and making sure we understand the minimum application rates and the minimum inlet pressures that we may be needing. So now I'm going to talk about some quick case studies, and I got photographs, and I think photographs are probably the best solution. So one of the first things I want to recommend and tell you everybody, high expansion foam is still good, still can use. It has no PFAS in it. So For our aircraft hangars and other places where we use high expansion foam, keep on using it, I say. No issues, no problems, right? So let's not throw out high expansion foam systems. So this is a photograph I got from a customer asking us to help them out. You notice the bladder tank way back in the back. My question to myself was, how is our technicians going to take that bladder tank out of that room without ripping out everything else or cutting a hole in the wall? The next picture on the other side is a flammable combustible liquid tank at a tank farm. We have a foam chamber up top, a riser that's uh, empty. It's a manual system. Um, the question comes into play with by using a new foam on this site. I most likely will need to replace the foam chamber up top. The question would be, do I replace the piping or not? And same thing with the other mechanisms. I will tell you my philosophy is we replace all piping. And the reason being is most likely the piping had foam at one time, therefore will have PFAS in it. And to my knowledge, I have not seen any scientific document proving that we can triple rinse or clean the piping to get rid of all PFAS. And I believe, and I tell my customers that I'd rather you get rid of it today to pay the cost today versus the cost tomorrow, because once the EPA or some other state regulates the cost of cleanup until they cause it a true hazmat waste disposal, the cost will increase exponentially. So those are the things I will tell my customers. The picture on the right, you'll see a 55-gallon drum of foam concentrate connected to a monitoring nozzle for a helistop. The odds of you ever doing this again are slim to none because of the listings of the temperature range of the foam. The temperature range here in the United States and Australia, we see the great swings of temperature, and leaving this outside in the sun will probably void the listings and void the application rates. So things to think about. These are two photographs I took at a flammable liquid warehouse. You notice the picture on the left, it's a rack storage, but there is no fuel space. The flue is gone. I don't know where it's supposed to be there, but they're storing it. So if the sprinkler system would ever activate, the water foam would never get down the middle of these racks. Additionally, there are sprinkler heads down here, but you can't see them. The other challenge we had at this site was they ran out of storage space. So they were storing full 55-gallon drums of flammable combustible liquids in the aisleway. Therefore, if we would have, yeah, you're laughing, right? Everybody's laughing at this photograph. So if we had a fire in the rack, it would hit, instead of worry about the other side of the rack, we're going to hit this target in the middle of it. So needless to say, after we visit this site, we had to write them a letter, tell them they're violating multiple code sections and to advise them to comply with the local codes and standards in order to take care of their problem. But that's the challenges, right? And then how to protect these different types of drums and containers we have. This is a multiple bladder tank sitting outside. I know this facility very well, been working on it for many years, trying to fix it. This will never happen again because of the temperature swings we have here in the States, from freezing to cold. These bladder tanks need to be inside an environment and controlled room to ensure that we comply with the listing requirements for the foam itself. So here's a diagram that I borrowed from somebody, and I blacked out their name to protect the innocence, but I think it's a great diagram. This diagram shows a typical riser arrangement that we may have. So we have the water coming up to a alarm check valve. We have a little fire department connection for water to come in. Moving up, we have a proportioner. To the right here, we have water going in to push into the bladder, and the foam pushes the foam out through the concentrate, through the proportioner, and on upward to the sprinkler heads and devices. So the question comes in, as we talked about listings, we know we're going to have to replace the bladder tank. We know we're going to have to do the proportioner, and we know we're going to have to do uh, the foam inside and the discharge heads. Now, where is PFAS? Well, I think we could all guarantee that there's PFAS in the discharge of foam concentrate from the top of the bladder tank on out to the proportioner. But if we tested the system at any time, or there was ever a discharge, I would say there was foam concentrate in, or foam, there was foam concentration solution and PFAS, most likely in all this piping. And we would say, hey, Mr. Owner, we probably should replace all the piping below at the flange level and just go on. Some customers do not wish to do that, and they only replace the minimum amount of piping. The challenge is when we start removing sprinkler heads or putting new sprinkler heads, as we fall in FPA 25, one of the first questions we should ask ourselves, when was the last time they did an internal inspection of the piping? And if we start doing some internal inspections of the piping, we find what I call sludge or other foreign material in there besides water, that requires us to do more internal inspections. And I will say most of the time we tear apart piping, we end up finding sludge, and the owner ends up removing all that sludge and removing all that piping because it's foam concentrate sludge. That's all it really is. So those are things we should think about. The other question is when we make foam, it's 3% foam concentrate and 97% water. Well, do you think the water supply coming into the site has PFAS already? I say it does, most likely. So we are telling our customers to test the water supply that the city is providing to see what the PFAS level is going into your system. Because I can make an argument, or a lawyer could potentially make an argument saying the city is responsible for 97% of the PFAS issue, and the owner is responsible for 3% of the PFAS issue, potentially. We haven't gotten to court yet with it, but it's something that the owner should have in his back pocket to help him out, to saying, hey, Mr. City, your water has PFAS also. So something to think about. And with that, that's my quick, dirty 20-minute session. Becca, do we want to open the questions from my PowerPoint, or just hold off for everybody for the next one?
We can take questions now. I would say for right now, let's limit it to maybe 5 to 10 minutes, because I want to make sure we have some time to get to the other presentation as well.
So do we unmute them, or do they want to just put it in the chat? Don't care.
They can do either or. So if anyone has any questions, you're welcome to unmute yourself. Or if you want to use the raise hand feature and we'll call on you, or you can enter it into the chat. But if there are no questions as of right now, then we can go ahead and move on to the next presentation.
Yeah. Sorry. Sorry. I have a question, or maybe a comment. Is probably more so. I'll just cover it in the presentation. Sorry, I'll do that. That'll be the best way of doing it.
Okay.
It's fine.
Hey, Joe.
Yeah, Doug.
It's Doug Myers. If you have any information on if the EPA is going to draw a line in the sand on the piping?
They have not drawn a line in the sand for the piping. We are using the 4 parts per trillion as our guideline right now, because that's the only number they have came out, and that's for drinking water now, grant you, right? So the question would be, where else do you go with that, right? And I think the challenge we all face is what number to use. I will tell you, all new systems that we're installing, we do not put in water or foam concentrate or solution on the ground. We're putting it in trucks and shipping it off, even though it's PFAS free. We're trying to be good stewards, I guess, Doug, if that makes sense.
Yeah, it does.
Right. And I think that's the challenge, right? How far do we go? I know some people don't go as far as we do, and that's okay. But do you want to be, liable later on down the road, I guess, is the challenge. And we have to be better stewards, I guess.
Yes. Okay, thank you.
Yep. Any other questions? All right. Carlo?
Okay. Right. Let's see how we do this. Sorry. Hold on a moment. Sorry. I'll just do something different. What are you doing here? It's gone again.
We can see your screen. You just need to make the
Yeah,
presentation larger.
Anyway, okay, fine, I'll do this. Hi, morning all from the other side of the world. This is just going through. This is a bit of a presentation that we did that was done for the Fire Protection Association meeting in Melbourne a few weeks ago. It's a little bit. It is just identifies how a couple of things that we're doing. One being where we are now in terms of a general status. We have a fairly the FPA has a fairly significant document to discuss foam fire protection generally in PFAS, as well as that we have another document which is calling up a bit of a shorter version of a foam transition process. So let's just get into it. I'll go that way. So this is where we're going. So we have IB6 is the selection of use of firefighting foams, as it says. It's basically how do you actually select it, how do you actually deal with phase outs, the various legislation. It picks up quite a few bits of obviously the Australian legislation, but it also picks up a few other legislations around the world. And as Joe was saying, generally these legislations are changing quite rapidly. A lot of it's coming out of Europe at the moment, which has a few different things. And then there's things like performance approvals and fit for purpose arrangements. So what I might do is I might just pop that document up. Go down here. So what I'll do is I'll just pop that document up. I think we the intention, Simon. I think the intention is to issue this IB6 to our colleagues.
Yes.
So I'll do this. These documents are actually quite significant. Sorry, does that come up? Has that come up on your screen? Has IB6 come up on the screen, please?
It has.
Yes, it has.
Yep. Okay. So if you go there, this is a 73-page document. So let's just not go down to too many pages. And this is just the table of content. I think that's probably all we need to do. It talks about firefighting foams, selection and use, which is what Joe touched on earlier, because you then have the type of, the firefighting performance, the impact, the environmental impact. And then, then you get the environmental regulations. And we have different, obviously, in Australia, because we are not one country, we're 6 different federations. We have all these different qualities, and there's different states have different criteria, which starts becoming a little bit interesting to deal with. And then we have all these. Then there's all these different other statements coming through. All these different legislations that we've picked up around the world. I think Europe has probably the more aggressive agenda. I think AFFF needs to be gone by the end of this decade. But they're also they're now doing parts per I think 50 parts per million is the on transition systems, because they've recognised that trying to clean out pipework and whatever is not easy. And then we have the different firefighting foams, fluoride-free, obviously the fluorinated, the C8s and C6s. The C8s obviously were supposedly removed 20 odd years ago and replaced with C6. And then we go down to a transition document, which is another one. And then we talk about environmental best practices and whatever. So that document will be available to you shortly, if it isn't already. So what we say is that so obviously this bulletin goes through the environmental impacts of per and poly, PFAS and the whole range of PFAS. It's not just PFOS and PFOA and PFHSA. There are multiple different components in the whole PFAS range, and that's creating. So when you look at one, you can actually quite comply with criteria of one or two or three of these, but then when you add in the component elements, you then have a different level as well. So that becomes the other issue. So then you have our compliances are obviously they're always evolving, they're always moving. I think, as I said, the European, the ECHA regulations in Europe are changing slightly. And that's being looked at now, and probably by the end of the year there might be another position on there as well. They're really quite aggressive about moving out their PFAS containing liquids. And then, as Joe also mentioned, we had the firefighting performance, which is obviously you have to test all this stuff and with the liquid that you're trying to protect against. That becomes a bit of a problem. The assumption, and I'll say this, and I think this is what Joe might have intimated on, the assumption that AFFF could work. I don't think that AFFF has been interrogated as far as what the fluorine-free foams have been. It's exactly the same issue as for those of us who have been around when the halons were transitioned away. The new products were always interrogated quite more rigorously than the old. And I also agree that how do some systems actually work with AFFF is beyond me sometimes when I look at them. We don't have too many photos of existing equipment, existing systems. We have clients get a little bit nervous about letting us show those photos. So unfortunately, there's no photos for us of this stuff. We can just talk about case studies. The system compatibility and equipment. That's right. Yeah, we talk about that. There is an issue about compatibility, and again, you can't expect manufacturers of foam products to undertake a test on every single sprinkler head or device that's been used in firefighting systems. It just can't happen. We'll be waiting for the next 20 years before we can work out whether or not we can use these. But the manufacturers, the Perimeter Solutions, Fomtech, and I believe the Johnson and National Foam, they also do internal testing of particular devices. So we here do a different process. Replacing out sprinkler heads in facilities or pipework is a different. We do it a little bit differently. We get that information that from the manufacturers to see whether or not the systems work, and we make that assessment, and that tends to be a little bit more acceptable. The contamination within the pipework becomes another issue. And there are companies that can do a chemical clean with very good results of the pipework and installations, but that's another issue. The system equipment and compatibility, correct. You cannot just drop this stuff in, foam out, foam in, and turn it on. It just won't work. Personally, I won't use bladder tanks ever again with fluorine-free foams. I don't. It's just the pressure, the pressure losses in that bladder system becomes a little bit difficult to manage. As an example, there's a project I did actually in Alabama where they used the bladder tank and they took the water supply from above the deage valve into the bladder tank and tried to put it back in, and that doesn't work. It took a lot of effort to make that work because you need additional pressure to go through the bladder tank to drive the fluorine-free foam through into the system. So you need to be very, very careful. We tend to use I tend to use mechanical dosing pumps of various types. Okay, so right. These are the different approval guides, and if you notice, they've all sort of changed. The fluorine-free foams, they've all gone through a testing process and qualities and applications. They've gone through all of this. They started off being, a lot of them were not there. Then eventually they got to a point where the fluorine-free foam met the criteria. So everything, even that process, because we're new it's not necessarily new, but we're moving forward. They're being tested more. They're being assessed more. They're now actually being passing more of the guides or the requirements. So again, that half of the installation, that half of the system, which is the liquid, is moving as well. The legislation is moving, the criteria is moving, the protection requirements are moving, but the foam is also moving in terms of quality compliance with the various regulations. And obviously, I think, and yes, they do have different application rates. They do have different expansion rates. The external factors are quite a bit more critical than with AFFF, simply because of the viscosity of the standing system. So that becomes a really quite bit of a process that we need to go through. So this is the sort of, just a broad arrangement of what broad process that we need to go through, which is, what foam do they have? This is really quite critical because people don't really know what they have. Do they have a C8 or do they have a C6 or do they have some other concoction? I think I worked on a project. I've worked on a few projects where it was the not to be pointing a finger at Justin, but it is the Werble special mix for the foam concentrate, which is a bit weird, but that was what was what was on the box. So we had to, so we needed to find out what that was to even work out where can we actually dispose it. So then review the regulations of the state, whatever it is. If you have to change the foam, you need to find a best way of doing that. And then you have to work our way through, and then you have to, one of the other parts of this, which I'll move to is to work out how to actually do it without actually impacting your client too much. So that IB6 does the document IB6 does that issue, goes through all of those in quite a bit more detail than what I've just gone through. But it's actually quite a very good reference document for everybody as well. And of course, everybody does things. I work around the world, and every country does things a little bit differently, so it's fine. You just have to work your way in your it's look at your facility, work out what's best for your facility, and then move forward with whatever rules are in place, which is difficult because the rules just keep on changing. So if we go to the next one, which is we produced a document, which is the IB25, which is I'll flip this up on the screen, which is a shortish transitioning document. This is like a guide to sort of rather than wade through 100 pages of IB6. We created this short transition project. You're already working on the project. You're already transitioning your phone. You've just made that decision. These are the sorts of things that you need to look at. So it's like whatever, audience background, whatever. And you go through this, and we'll talk about this diagram in a bit. So this is where we go through everything. So we'll just put that to the side, and we'll talk about it and come back to that flow chart. So when there's a decision made that we have to transition away from AFFF, you need to actually go in and understand what's there. You need to go and find out how the facility is built, how you actually going to modify it, as Joe's photo. How do you get to that bladder tank at the back of everything? You need to work out what the client wants, but what the critical issue is what we find a lot of pushback on is to try and determine what the PFAS contamination levels are, because people don't, let's be blunt, clients don't really think fire protection systems is really all that important until they go off, and they don't really want to pay for the money of something that just basically sits there for maybe once that it happens, but they really want it to happen at the same time, work at the same time. So the start of all of the transition is to work out what level of contamination that you have. So we currently working on a hangar project where contamination levels are inside the water mix side is actually quite low, actually below the level, the mandated levels. However, the concentrate is actually higher. So that's actually quite a simple thing. So, well, relatively simple. We have to just make it all sort of work. So but I have other projects where the contamination's all the way through the pipework. So what do we do there? So the transition design, this is what you need to pick. You have to choose your solution, choose your foam concentrate. Based on regulatory requirements, obviously PFAS free. There's another item that's coming up soon that'll start poking its head up. It's about siloxanes. That'll be the sort of probably less of an issue, but sort of coming across the range at the moment. You then need to look at has the protected facility changed? Now, if you have a look at fuel farms or bulk storage facilities, they're always changing. So whether or not you actually, whether or not they're going to use a combustible liquid or not, or flammable liquid or not in those tanks, which means you don't need the fire protection system, or do you do inside of the my background's mainly on aircraft hangars. Do you actually need to have a foam system inside the hangar? It's really quite a scary thing to say, but we're doing aircraft hangars without foam now. So you range from doing a full change out of all pipework, all equipment, or you try and clean it. You have to obviously replace all the components and all the rest of it that's required. But then you could also say, do we actually need the fire system altogether? Which is, that's also another transition process. You need to, whenever you do these transitions, you need to actually look at the operational costs or the opportunity costs or whatever. So in a bulk fuel storage facility, you can't really shut down, 10 storage tanks for an extended period while you're there changing around the pipework. So because the cost of the shutting down those tanks is going to cost more than the fire system. So if you're replacing the entire fire system, you might have to double or triple the price of the fire system, but that might wind up being the cost, by doing a staging process rather than shutting down the tank system. So you need to consider that as well. If you want to go down the decontamination process and procedures and whatever, you need to work out how are you going to decontaminate the system, chemical flushing, water flushing, depending on the levels of concentration in the system. And then you need to develop a foam transition plan, and then you have to, so that everybody, before you even start the transition, you need to know where the end point is, or even the pathway there. Because if you don't have that, you can find yourself in a really, really difficult position because you can't get things in time, you can't dispose of the equipment, and then you need to actually get to the regulator as well to make sure that that's all happening. So if you're, transition execution, you need to actually have all your procedures in place, obviously, and you need to be willing to accept that that's going to change a little bit along the way. And then you have to deal with a functional test workplace. So, fine, I am now not doing any foam discharge tests on any system. I don't create foam. I don't create bubbles. Sorry, I don't use. High expansion foam is probably a little bit different, but I do not do any foam discharge test. Using mechanical dosing systems, you can actually bypass the foam, bypass the creation of foam mix, and you send everything back to the tanks. So the water goes back to the water tank if you're using one, and the foam concentrate goes back to the foam concentrate tank, and that allows you not to do the foam discharge, because irrespective of the type of foam that we are now in Australia, we are now living in a regime where we can't do a discharge of foam to the environment of any foam, and that's so you basically have to collect everything. You have to collect everything. You need to have containment tanks if you do have a discharge in the system. And basically the cost of doing a test, replacing the foam is a driving force of that as well. The waste management and the disposal is becoming a really big issue here. And it will, no doubt, become an issue with yourselves as well, because the only way you can destroy PFAS is to basically incinerate it in a high temperature incinerator or a high temperature system, which is sort of works well, but there's limited incinerators around the place. There's been some studies in Australia and some systems that are working that they're using cement kilns. So creating cement needs water, and it also is above 1200 degrees. So that actually does a double purpose. It provides water for the cement manufacturer as well as killing off the PFAS. That's an example of the ways that things are happening. Problem we've seen with waste treatment facilities at the moment is that they're quite okay dealing with water, the liquid. The solid waste becomes an issue. There was a case a couple of months ago where in Australia where the inspectors went through and did a sampling of the soil around their solid waste storage area, and it's all PFAS contaminated because the guys just lob the pipework on the ground, and obviously it rains a little bit and it leaches out because they don't want to. The only way you get rid of solid waste is obviously shoving it into a steel manufacturing process. But they don't do that on a daily basis. They like to collect it. So there's a whole procedure that needs to happen about the waste. The whole waste disposal procedure is a bit of an issue as well. So in terms of the transition process, this was actually produced for a project in Singapore as part of a bid phase. This is a procedure that we did, and it looks like there's a lot of boxes. And I can tell you that the same procedure occurs even if it's a very, very simple process. You need to look at the documentation that you have on, you're over here. You need to look at the documentation that you have on the existing systems. You need to do an inspect. You need to investigate the PFAS concentration that's inside the system. That includes the water storage tank, as you mentioned by Joe, and all the municipality water system. Then the preliminary design process is in the middle. That looks like a lot of boxes that go round and round and round in circles, and it's there. But it's what you do. It's what engineers do. That's you say we're going to do this one. Here's another option. We'll look at that, and then we come up with a selected design. And that within part of that is the cost benefit analysis, and that must include the operational impacts, as mentioned before. So then you create can you do a clean out? Yes or no. Preliminary, you do schedule of work. You go and see the authorities. You work out what the final operational impact is. You work out the volumes, and you do the final design. And then here's the draft transition plan. And then you go and have a look at it. And then you wind up with a transition plan. And then at that point, you then start doing the work. So that's that short version. That graph there. That graph there is a transition process. So that's covered over in IB 25. So that's the end. Obviously, questions away, and James decided to put his primitive solutions. Sorry, we forgot to take that off, Simon. It should have been taken off the slide, as well as that piece there. So. So that's where we are. So this is okay. That was the panel session for the FPA conference. Thank you. So questions.
Carlo, this is Joe McElveen again. I think you hit something that's really important is when we're looking at the existing systems and we're evaluating them, foam may not be the right answer for the hazard, right?
Correct.
And we may be able to go with a sprinkler system or something else, and we need to keep an open mind about that situation, I think, so that we just don't go down the rabbit hole, I guess, so to speak.
For example, dangerous goods stores is one. So it depends on where you sit. I mean, if it's it comes down to what's changed as well, because a lot of these things were put in years ago. years ago. So has it stayed the same?
Yeah, they were making widgets, and now they're making something totally different, right? With some different chemicals and everything else. So,
Yes.
right. What's interesting what I hear from you though is that it sounds like Australia is okay with reusing existing piping in some places. Is that a fair statement to say?
Yes. With obviously the proviso that the it needs to be demonstrated that you reach the required minimum mandated levels. Because obviously there's no way an existing system will ever be cleaned 100%, and you will get rebound. But you need to make an assessment there about there's if you need to be able to reach the mandated levels, and not just by you know 1 part per trillion or whatever it is. You need to be able to make it quite comfortably. The other one of the case study one of the projects we did, it's an aircraft hangar water supply. And over the years, because you're returning the water back to the tank during testing and all the rest of it, yes, the contamination, the foam concentrate went back into the tanks, and then went back up into the water, back into the pumps, and the pumps took it back into the tank. So the tanks were contaminated, as I would imagine every single aircraft hangar that was built up to about yesterday. The firewater tanks would also be contaminated.
Mm-hmm. Yeah, that's why I recommend testing the water supply to see what the level of PFAS is coming in, right?
Correct. Correct.
That's your baseline.
Yep.
Exactly.
When you're testing the system, you need to test the whole system, the entire system, which is not from the pumps out. It's actually from water supply, the water supply out. But the issue about that system, there was a decision. Yeah, there's 6 million liters of liquid of water, and the choice was either to dispose of that was about, at that rate, it was about $2 a litre. Do that sum, it's like $12 million, and then clean the tanks. But so he said, well, if we drain this, where does it go? It goes off into one of these chemical drains that's called Sydney waterways, and they found that the waterway was actually more heavily contaminated than the water tanks. So it didn't make any difference. So we didn't have to clean the tanks. So this is what I'm saying. It's not just because you have contaminated systems doesn't mean that you just have to replace everything or even clean everything, because you need to look at the system lives in an environment which may also be heavily impacted. So what do you do? And obviously you're not going to, cleaning the waterway. How do you deal with that? That's why you need to work out.
Yeah, and I think that's what the unique differences between us and you guys down there is. Our environmental people are more leaning towards replacing everything, on being on the safe side because of the unknown factor, right? And all the lawsuits that are being filed against everybody, and then even our insurance that we have to protect ourselves, is leaning that way to do certain things and I don't know if that's the right answer, like you said. How clean is clean, right? I think about the days my mom used to yell at me to make sure I clean behind my ears, right? So I guess that's the question, right?
Well, we had that comment out of somebody in Singapore that said, "Oh, how free is PFAS-free concentrate?" You know, you can't answer that question. Well, it's PFAS free because the manufacturers have tested it and it's PFAS free. But is it really free? Is it zero, or is it point? Is it 1 part per billion? But you can't actually. I think they're starting to be able to sample down to that point. Joe, sorry, while we're talking about parts per million, the water supply criteria is 1 part per trillion. Did you say
4 parts per trillion?
4 parts per trillion?
Yeah, yeah. There's not
How do they measure that?
most water departments, the water purveyors are not able to test that far. There's only a couple laboratories that I know that are willing to do that far. Which is scary because how do you do that, right?
Four
You know,
parts per
we,
trillion.
yeah, we all think about millions, right? Parts per millions and parts per billions is okay to a certain thing, but trillions are extra zeros and commas that we don't typically, even when we win the lottery here, we don't win trillions, you know? So it's just one of those things. And that's just
See,
for drinking water. The EPA, our EPA, our federal EPA, and our state EPAs really hasn't, as one of the questions asked to me was, where are they going with piping and fire protection systems, right? And they have not gone down this path. And in some ways, I think we're afraid to ask the question because sometimes if you ask that question, they may regulate us even farther down the road, right? And I think we're trying to um, take some good examples and follow some good leads and tell the EPA when they start asking questions where we're at. Just like we all think about the Halon days and Montreal Protocol and the HFC gases and reductions, right? We'll keep on getting regulated more and more. And as you said, the European market and European regulatories are the ones who are driving all of us crazy sometimes because they think of a regulation and then they share it with their friends here in the United States or their friends in Australia, and they think it's the best thing since sliced bread.
Yeah, I think so. Just on the Europeans, they're on uh, foam foam systems that are being undertaken so that they have a transition program done on it. I think they're changing the residual contamination to 50 parts per million, 50,000 parts per billion, because they recognize that trying to get to, parts, under 10 parts per billion is just really, basically, that means you have to replace the pipework, everything, which is just horrendous.
And that's where we're
So,
at. Yeah, and that's where we're at here in the
well,
States. And like that's where,
yeah,
and the question comes out is, I know what my cost is today to replace the pipe and to take the pipe away and the sludge and the water to be disposed
yeah,
of properly. We know the odds of to dispose of it 10 years from now is going to be higher, right?
well,
Or
you're running
more.
out of space.
Yeah,
Yeah, you've
yeah,
run out of
right.
space as well. Yeah.
Yeah. So do you pay today or do you pay tomorrow's costs? Which
Yeah.
way do you go? I think, and I think it gets, uh, and then we're finding some owners who have locked out their foam system without telling anybody, and just have a sprinkler system, and we're saying you can't do that, and that's a deficiency. Your building was designed for a foam system because you were storing something
Whatever.
that
Yeah.
required it, right, at one time. Now you need to do a risk assessment to evaluate it if you can really remove the foam system, or do you need a foam system or something else?
Whether
And
or not there's or whether or not there's residual PFAS in the pipework.
oh yeah, yeah, it's I guess you can say we're going to have a job for a long time.
All
Well,
right.
not,
Well, we are just at the top of the hour. So if there are any final thoughts, we're going to end the webinar. All right, perfect.
well,
The
right. Thank
webinar,
you. Thank you for letting us do it. It's good.
of course, yeah, the webinar was recorded. So it will be posted on both FSSA and FPA's website for future viewing. Thank you,
Thank you very
everyone.
much. Just bye.